Hi, my name is Santosh Balasubramanian. I'm a program manager in the SQL Server group working on high availability and disaster recovery solutions. I'm here to talk to you about always on availability groups and give a deep dive on it. A quick recap of the agenda. I'll give a recap of always on, talk about some of the features, why we did this, then go through a demo of upgrading from database mirroring and log shipping while running an application to always on availability groups, show you the connection experience to connect to the primary of your availability group from the application, multiple secondaries, multiple databases, then show you the active secondaries feature, do a demo where we will we'll take a backup from one of the secondaries, seed a new DR site and add that DR site to the availability group. Then we will use that DR site to run our reporting or read-only applications against. After that, we will jump into quorum configurations, why we need it, do a quick demo for it, and end with the disaster recovery scenarios, do a quick demo for that as well. All right, let's get started. Microsoft SQL Server high availability and disaster recovery solutions are currently being used to run mission critical applications. We have solutions such as database mirroring for database level protection, SQL Server failover cluster instance for instance level protection, and log shipping, which is used very commonly for disaster recovery solutions. We have a lot of customers such as BWin, ServiceU, Care Group, and many more who are using these solutions. A lot of times, depending on the topology of the customer, they use a multiple set of solutions together. For example, if the topology requires local high availability and a disaster recovery site, so think about your local data center and a DR site, customers use things such as database mirroring for local high availability and log shipping in the same topology for your DR site. When we started planning for SQL 2012 HADR solutions, we took a step back and thought more holistically about the space. Some of these things which I was saying, right? Customers are using multiple solutions for their topology. These are some of the pain points, some of the and additional feature gaps, feature analysis that we actually did. And apart from that, we also look at future trends. What is the technology that we want to build the future of SQL Server high availability and disaster recovery on? So based on that, we came up with 3 pivots. We want our new solution to be unified and simplified solution. What that means is a single solution for all your different topology needs. No more thinking about things like database mirroring and log shipping or SQL Server failover cluster instances and database mirroring. Just a single solution for your topology, which needs to be easy to deploy and manage. We want the solution to be flexible. That means that if in your existing infrastructure you have shared storage, you should be able to use that. If you have direct attached storage, you should be able to use that. You should be able to use both of these in the same solution. And we want this to be efficient. What this means is all the hardware that you have procured for your HADR, we want you to be able to utilize them. No idle systems. And we came up with these 2 new solutions. Always on availability groups for database level protection and always on failover cluster instance for instance level protection. Always on availability group is what I'm going to talk about and demo and go into a deep dive in this session. Quick recap, failover cluster instances is basically the additional features which we have added on top of our current SQL Server failover cluster instances. Additional features such as multi-site clustering, flexible failover policy, better diagnostics, consolidation scenarios, removing the drive letter limitation, and TempDB on local for all practical purposes. So let me jump into always on availability groups. The major features of always on availability groups are we allow you to take a set of databases and add this set of databases to an availability group and fail over the availability group. So all the databases will fail over together. I will compare and contrast this with mirroring. In mirroring, database mirroring, you can only have one database that you can set mirroring on. So if your application depends on multiple databases, you'll have to set up mirroring on each one of the databases and fail over all of these databases, right? But in availability group, this is the advantage of your multi-database failover. Next, you can have multiple secondaries. In mirroring, you can have only one passive mirror. In always-on availability groups, you can have up to 4 secondaries. Out of these 4 secondaries, 2 can be synchronous, and one of these 2 synchronous secondaries can be an automatic failover pair. So now let us bring this back into your topology. You can have one synchronous secondary in your local HA, and you can have another synchronous secondary for your local HA, for your regional HA, and you can have 2 secondaries for your DR site, which could be asynchronous, which leads to the next point. You can have either synchronous or asynchronous data movement in your availability group. We have the features of mirroring such as compression, encryption, automatic page repair, automatic or manual or force failovers as well in always-on availability groups. And we also have the concept of flexible failover policy. What this means is we have a stored procedure which is running in your SQL Server instance, which sends health information of the instance and monitors that. You as a customer have a setting that you can say, for what error or what error condition do I want my failover to happen? Please go to MSDN Books Online to read a little more about this feature. Integrated. Failover is more than just the failover of databases. Also, your application must failover, correct? So you do not want to change your application connection string. Now your application can connect to one of 5 servers, 1 primary and 4 secondaries. How do we actually allow you to achieve that? We do this using the virtual network name. I'm going to demo this as well. We have done a lot of work into making the configuration easier by providing a configuration wizard. We have a dashboard which shows the health of your availability groups, the servers or the replicas in your availability group, as well as the databases in each of those replicas. We have rich COM integration, rich diagnostics infrastructure. For replication, we support publisher failover, very similar with mirroring. We also support contained database, file stream, file table, and service broker. Efficient. As I mentioned earlier, we want you to be able to use all the assets which you have procured for your high availability and disaster recovery. We do this by allowing you to make your secondaries active. We allow you to do your read-only workloads or your backup workloads from your secondary. Another way to also look at this is the more resources you can remove from your primary and push it towards your secondary, the more the availability of your primary as well. I'm going to do a demo of this feature as well. And all of this that I'm talking about, your creation, management, failover, everything can be done using PowerShell scripts. All right, so let's assume a customer scenario. The customer has been said that I want local high availability and I want a regional HA site or a DR site. Currently what the customer would be doing, he might be doing something like setting up database mirroring for local high availability and log shipping for your DR site. In my scenario, I'm using AlwaysOn SRv2 and AlwaysOn SRv3 for database mirroring, and AlwaysOn SRv4 is my log shipping target. Let us convert this into an availability group. I'm going to jump into my demo right now. All right. So what I have here is AlwaysOn SRv2, which is my principal for my mirror with 2 databases, and each of these have been mirrored to AlwaysOn SRv3 which is my mirror for both the databases. And my AlwaysOn SRv4 is the log shipping target, as you can see this. So if I do refresh, you can see it as the log shipping target. All right. Let's convert this into availability group. Before doing that, let me start an application, because what I want to show you is while this application is running without any downtime, you can convert your database mirroring and log shipping to availability groups. So this application is doing some inserts into our principal currently. The first thing that you need to do when you set up an availability group is make sure that all the servers which are part of your availability group are in the same Windows Server failover cluster. To create a Windows Server failover cluster, you can go to the failover cluster manager, right click, say create a cluster, next select all the servers, AlwaysOn SRv2, AlwaysOn SRv3, AlwaysOn SRv4, and AlwaysOn SRv5. I'm going to add this right now, and this will be my DR site in the end of the demo. Next, I'm going to give this cluster a name. This name is not being used by availability group. This is purely for managing the cluster. So I'll just call this business CLS. Click next, next, and now we are going and creating a cluster. So basically clustering all of these 4 servers that we had. One of the very important things to note is each of these servers have their own direct attached storage. They do not have shared storage. Shared storage was a requirement with SQL Server failover cluster instance or even AlwaysOn failover cluster instance. With this, what you could do is each of the machines are only a part of your Windows Server failover cluster, but they do not need to have shared storage. One of the other essential things to note here, if certain of your machines are across subnets, so say you have your AlwaysOn SRv2 and AlwaysOn SRv3 in one particular local data center. AlwaysOn SRv4 is in another data center, which is your regional site. AlwaysOn SRv5 is in yet another data center, which is your DR site. All of these would need to be the part of the same Windows Server failover cluster. So you have to use the stretch clustering concept for it. Right now, my cluster is being created. This is a virtual machine. All of these virtual machines are running on my laptop. Hence, the cluster creation is taking a bit of time. But while this cluster is being created, what I do want to show you is our application is still running. What this means is there is no downtime for the customers at this point. The customers are still keeping on going, and they haven't lost their business connectivity. They're still working on database mirroring, so there is no data loss happening for them. They still have log shipping. So we are doing this in parallel without impacting the customer workloads or anything. While the cluster creation happens, let me go back and check if it is created. Here, our cluster has been created. It's created the cluster across all the nodes. I will click finish here and jump back. Sorry. I'm going to jump back to SSMS, show you again. The cluster was created. Your application is still going. Your customers are still connected. Now, the next thing we need to do before we set up an availability group is make sure that we give your SQL Server permissions to create resources in your cluster. The way we do that is you go to SQL Server, you open up SQL Server Configuration Manager, go to the service on each one of the servers, right click, go to Properties, you see this new tab called Always On High Availability. We automatically populate what cluster is the server a part of. You select Enable Always On High Availability and click OK, then you have to restart the service. Alright, actually I'm not going to do this because I would have had to do this on each one of the servers. I will show you how we can do this using PowerShell. So you can script this out and automate this process. So I have some PowerShell scripts right now. I have this, which is SQL enable always on AG. I am going to each one of my servers and I'm going to say for always on SRV 2, 3, 4, 5, enable SQL Server always on. I have PowerShell and let me run this. SQL CM enable always on AG. So what it is doing while we run the script is it's going to each one of these servers, it is checking the checkbox, and it's going to restart the service. While this is going on, we can actually just see here, like always on SRV2 is being restarted right now. Next, the script has to connect to SRV3, restart it. While this is happening, one of the things which I wanted to talk about is what are we doing for data movement? Like how do we make sure that the data between all of these different servers in an availability group, how do we do the data movement in them? We use very similar to database mirroring technology. What we do is we do physical log movement for your availability group. All right. So now what has happened is the script is still chugging along. It has restarted. It has enabled always on availability groups for SRV2, SRV3, SRV4, and now it is working on SRV5. However, we can start moving our database mirroring and log shipping configuration because we are only going to do it for SRV2, 3, and 4 right now. So let me show you the application is still running. The first thing I will do is, just for the purposes of this demo, is disable my log shipping jobs. Sorry, the SQL Server agent did not get restarted when I did the restart of the service. So I'll just restart the agent. Okay. Before disabling the log shipping jobs, what I'll do is I'll make sure that the log is there on the DR side, which is SRV4. So for this, I'm just going to run the jobs really fast. Right now, I'm running the job for AdventureWorks DW. And actually, in parallel, I can also start the job for always on AdventureWorks Ref, which is my second database. Let us see if the first job is completed. It is completed. The second one is completed as well. Let me do the restore. I'm just doing this so that I don't have to chase logs around. So let me do the copy job first. Actually, I will start both the copy jobs at the same time. And once this finishes, I'll do the restore job. This just in the purposes of the demo, make sure everything is working correctly. Okay, now let's do the restore jobs. Start the other restore job. So we are restoring the databases. This is all just log shipping, so it's just logs. I'm just forcing this right now rather than it going through its own process. Once these jobs are completed, I will disable the log shipping job just so that no log truncation happens in the middle of my process. And now let's start the conversion process. Your customer is still not disconnected. Your customer still has the data protected across your principal and mirror. Okay, the first step I need to do is disable mirroring. For that, I am going to go select the database, go to mirror, select remove mirroring. Okay, I'm going to go to the next database, remove mirroring for this one. Okay, let me refresh and show you that the mirror has been removed from both. Then I will start creating my availability group. No downtime for customer, but let me create the availability group right now. For this, I select availability groups, right click, new availability group wizard, click next, specify a name of the availability group. Let me just say business app AG. Click next, select databases. As I mentioned, I can have multiple databases in my availability group. Next, select the replicas. So until now, I was talking about the servers, which is there in your local data center, your regional data center, your DR site. What we call these in availability groups is replicas. You can have your primary replica and your secondary replicas. So AlwaysOn SRv2 is my primary replica. Let me add AlwaysOn SRv3. This is my secondary replica, which is there in the same local data center. I want synchronous data movement between the two of these, and I want automatic failover between the two of these. Now let me add my third replica, which is AlwaysOn SRv4. This, if you remember, was what I did log shipping against. But now I can add this as a part of my availability group, a single unified solution. That's what we were talking about. Another thing to note is I can set this up as synchronous as well. So now you have two locations where you can actually save your data. Next, I will set up what I call the listener. So if you remember what I had shown, what do you use to connect to the primary of your availability group from your application? We call that the availability group listener. Let me give it some listener name. I'll call it business con for connection 1433, just a default port, DHCP. I could do static IP as well, which we recommend or which we require for multi-subnet setups. But in this, all of them are in the same subnet, in the same VM, hence I'm doing it this way. Go back to my replicas, click next. These are some options for data synchronization. I can do a backup of everything, of each of the databases, and get it restored in each one of the secondaries. Or I can do join only. This means I've already seeded the databases in the secondaries. In this case, I'm going to just do join only because I had mirroring and I had log shipping, so my databases were already seeded. And the last thing is I can just create an availability group and seed the databases on the secondaries later and join them later. But right now, I want to create my availability group in one shot. We do go through some pre-validations, a summary of what needs to be done. You can script this out as well. I click finish and we are creating our availability group. We configured the endpoints. We are now creating the availability group, creating the listener. This is the virtual network name through which you can connect to your availability group. After this, we will join each of the secondary replicas. So the secondary replicas is SRv3 and SRv4 to the availability groups. Then we are joining each of the databases to the availability group as well. And there we have completed our availability group. One thing to note, customer, no downtime. We are using the failover partner connection string, which was there on your application previously, which was used for mirroring, and still keeping the customer up on the customer's application up, even though now we moved your database mirroring and log shipping to an AlwaysOn availability group. So let me show the dashboard. How I do that is I can select the availability group, right click, say show dashboard. Here you can see you have your primary on SRv2, secondary on SRv3. Both of these are automatic failover targets. SRv4 is your regional HA site, which you wanted it to be synchronized. Synchronized means there is no data loss. And Also, you can see all the databases are synchronized at this point. We have a bunch of other options that we allow you to see, so you can monitor things in a single place. For example, I can select availability mode. You can see how I had done the initial configuration of this availability group. We have a bunch of options here as well, logs and queue, logs and rate, and other things in your dashboard. It's a very powerful tool at this point. All right. So I moved your database mirroring and log shipping to always on availability group. Let me show you how I can use the listener right now. For using the listener, I need to change the data source. So I'm just going to stop this application right now because I'm going to change the data source to the listener name for the availability group which we had done, which was business, con, and I'm going to remove the failover partner and click on change and start the application. You see that you're automatically connected to the new primary at this point, which is AlwaysOn SRV2. All right, now let me do a quick failover and show you that we are always connected. This listener will reconnect you automatically to your new primary. I'm going to keep the app running on the side. That's why I'm actually just minimizing this, because I want to show you the app as well will reconnect. I will initiate my failover. We have the failover wizard to do that. I want to show you the app, hence I'm going to move things around a little bit. Click next in the failover wizard. I select the replica that I want to failover to. In this case, I want to failover to, say, AlwaysOn SRV3. So the situation is probably I want to patch SRV2. So I want to do the failover, patch it. I select AlwaysOn SRV3, click next, connect to it through the wizard, next, finish, and now the failover is happening. Your application is down right now because there is no primary. We are now going through the process where we are bringing AlwaysOn SRV3, which is my new primary, online. AlwaysOn SRV3, my new primary, is already online. Depending on the reconnect logic that you have built into your application, it will reconnect to your primary automatically. You have to build the reconnect logic though into your application, as you saw. And here you see I haven't changed anything in the data source. I'm still using the listener name, BusinessCon, and I got automatically connected to my new primary, which is AlwaysOn SRV3. All right. Let us jump back into the slides right now. I'll start from the current slides. So let's do a recap of what we did. We converted AlwaysOn SRV2 and AlwaysOn SRV3 database mirroring and SRV4 log shipping into a single availability group. We had our application running while we did this. So this is our new topology now. All of this is a part of a single availability group. Data is being protected across multiple secondaries. So what is the advantage of our new topology, of our new solution? Better SLAs, multiple locations of no data loss, better data protection through continuous replication. So previously in log shipping, it depends on what time you set up your log shipping, correct? Like what is the interval for log shipping? In this case, there is continuous replication that is happening. Even in asynchronous mode, we are always sending the log blocks from your primaries to your secondaries. Faster failover, because now even if you fail over to your DR site, so even if I failed over to my AlwaysOn SRV4, I would be able to use the listener name and connect from my application automatically to that. Even if it was in different subnets, we have actually done some work. You would have to use a keyword called multi-subnet failover equals yes. And if you use that, then the failover of your connection string becomes much faster. Please look online in our books online to read more about that. So what is the other things in our new solution? You have a unified solution, no longer multiple solution. Simple deployment, everything I showed you through Wizard. You can do this using scripts or also using PowerShell. Unified dashboard, a single place where you can see the health of your availability group, your primary replica, your secondary replicas, all the databases in your replicas. So assume there is a situation where there are 50 databases in your replicas. All of that you can see in a single place. Rich diagnostics is also provided on top of this. Single centralized management of your client connection using the availability group listener, and multiple databases in your availability group. So all the databases fail over together from your availability group. One of the things that I wanted to add is initially when I moved from your database mirroring to AlwaysOn availability group, I was using the failover partner connection string, and your application was still getting connected to your primary. One of the things with failover partner connection string, we did that just so that your application doesn't have any downtime. We always recommend go to use availability group listeners, especially in cases where you have multiple secondaries. Failover partner connection string can be only used if you have only one secondary, and that secondary cannot be readable. Okay? That's why we recommend always use availability group listeners. All right. So now let me talk about active secondaries. How can you utilize the secondaries which was there in your availability group? You can do this using two ways. You can either move your backup workloads from your primary to your secondaries, or you can do reads of your secondaries. So you can point your read-only applications, reporting applications to your secondaries. All right, let me do a demo of backup from secondaries. I'm going to go back to my demo machine. I'm going to close out the previous things that was there. Actually minimize this application and expand SSMS. I'm going to do most of the demos directly from SSMS in this case. So let us look at your availability group right now. I've failed over to AlwaysOn SRv3. So I had to refresh this. And this is your primary in this case. Go to your availability group, show the dashboard. That shows the same thing. SRv3 is your primary, SRv2 is your secondary, and SRv4 is another secondary. What I'm going to do is I'm going to take a backup from AlwaysOn SRv4, seed a new server, which is AlwaysOn SRv5, and add AlwaysOn SRv5, which will be our DR site, to the availability group. All right. In order to do that, the first thing which I'm going to show you is this concept called backup preferences. So how do you do your backup secondaries? How do you set up the order of backups? For that, I go to AlwaysOn SRv3, which is my primary, right-click the availability group, go to properties. Here you can see a property called backup preferences. What does this mean? Imagine you can do backups from all your primaries and secondaries. Then I can start filtering down these lists with my preferences. So the first is prefer secondary. So if my secondaries are online, I want to use my secondaries for a backup. If they are not, only then use the primary. Secondary only. I never want to do backups from my primary. For that, you will select that option. Primary only. I never want to do backups from my secondaries. I want to always do it only from my primary. Any replica. I can do backups from any replica. For purposes of this demo, I'm going to select prefer secondaries. And now let us go to the second thing, which is backup priorities. What this means is, because I could have multiple secondaries, which secondary do I really want to take up the backup from if I want to automate this process? Say I want to take this backup from AlwaysOn SRv4. So I will set this up to a higher priority order. SRv3, if SRv4 is not there, I will set that to something higher, and last SRv2. So see my priority orders. The other thing I could do is I could also exclude these replicas, say that I never want to take backups from some of these replicas. All right. Now that we have set up the priority order and the backup preference, let me show you how this is actually utilized. What I have, let me close this and see if I have the script open here. Yes, I have my script open here. What we have provided is a function which will say for a particular database, is this particular replica that I am running I want to run my backup from, is it the preferred replica or not? For example, in this case, we have connected to AlwaysOn SRv2. It is a secondary, but the priority order was low. So we are saying that, no, this is not the preferred replica where I want to take my backup from. Let me connect to the primary. Remember, we had done that, we had set that I prefer that I do my backups only from my secondaries. So even here, it should say, no, this is not the preferred replica that I want to do my backups from. Now let me connect to SRv4, which is my secondary and was the replica that I wanted to do my backup from. When I run the script, you say, yes, this is the preferred replica that I want to do my backup from for the database which is in my availability group. The place where you can use something like this is for things like log shipping, or if you have your own custom jobs to take backups. You can set your backup priority order, put this function on the top of your job which is taking your backups, and say only when it matches the criteria that I have set do I want to take my backup. So in this case, if I had the job running on all my replicas, SRv2, SRv3, or SRv4, the first thing it will do is check this function and say, wow, you SRv2 or SRv3, you're not the preferred replicas. When it runs on SRv4, it will run this function and say, yes, this is where I need to take my backup from. All right. Now let me take the backup from AlwaysOn SRv4. For that, I am going to go select my database. I'm sorry, I have to also refresh this just to show you that it is synchronized. I had forgotten to refresh this earlier. I had connected it earlier. Go to Tasks, Backup. I am going to do a full backup. One of the things is when you do backup from secondary, you can only do copy-only full backups and initiate the backup process. Actually, I'm going to redo this, and the main reason I'm going to redo this is I wanted to go to a different share. In this particular demo, I made it go to a common share, but I actually wanted to go to another share where I can show another functionality. So let me actually do this backup once again. So I want to do this backup again. I'm going to do the copy only full backup. I'm going to remove this. I have another share which I'm calling AlwaysOn SRv5 seed share, and I'm going to call this addw 1.back. Okay, so now it is actually taking the backup to the share that I want to show you another functionality from. Important things to note, you can do only copy-only full backups or log backups from your secondaries. Okay, the backup is completed. I'm going to go to AdventureWorks ref, do exactly the same thing, do a backup, copy-only full backup, remove this, add the share which I had wanted, which is AlwaysOn SRv5 seed share, and I'm going to call this add ref 1.back and click OK. Smaller database, it got completed immediately. Now let me go to my DR site, which doesn't have these databases, and let me restore it. To restore it, I'm going to go to the share which I had done, which is AlwaysOn SRv5 / seed share, refresh. You see there are a bunch of backups. I'm just going to select all of them, click add. Oh, sorry, I should have clicked OK, but I clicked add there. I'm going to click OK. So it's going through reading all this backups and telling me for AdventureWorks DW, the latest backup is this copy only full backup, which you just took right now. I'll also set up the options to restore with no recovery. Go back. Before I click OK, I wanted to show you a new function, which is a new thing that we have done, which is this recovery wizard. In this demo right now, I only took one backup, but if I had taken multiple backups, you can assume what would have happened. We show what are all the backups that have been taken, irrespective in the share that you have, and what is the point of backup that you can do it was taken to. So now you can restore to a point in time and an easy view to see which backup you actually want to restore. Okay. In this case, I'm just doing the latest one. We're going to the restore of this gig database. And as you notice, I did restore with no recovery because I want this to join the availability group. This backup is completed. The database is in restoring state. Now let me restore the second backup. For that, I'm going to do the same thing. Click on add, Control A, delete, always on SRV5, seed share, refresh. I'm just going to select all the backup files, click add. Oh, sorry, I did this again. Click OK. It's reading the files. I just wanted to show you that if I want, I can pick the latest file. I picked ref. It is picking our latest backup, which I just did from AlwaysOn SRV4, which was my secondary. Click OK. And this has been restored. Oh, I am sorry, I did a mistake here. I should have restored with no recovery. That's okay. I'm just going to delete this and show you the restore again. I go back to the databases, device, add. My sincere apologies, I had to redo this. I should have done restore with no recovery, SRV5, seed share, refresh, Control A, OK, OK, select AdventureWorks ref, go to options this time, select restore with no recovery, and let's do the restore. So now you have both the databases in in AlwaysOn SRV5, which is your DR site. What I did is I took a backup from the secondary and restored it here. Let me add it to the availability group. To do that, I need to go back to my availability group. Any of the configuration changes, like adding databases, adding new replicas, everything needs to be done always from the primary. I'm going to use the wizard to add the new replica. So I select my availability group, right click, select add replica, go to next, connect to the existing replicas which are already a part of the availability group, click next, add my new replica, which is my DR site. This has to be asynchronous because we allow only 2 synchronous secondaries, which I've already used. Click next. I can do join only because I've already seeded this replica or DR site. Next, next, script it out if I want to, but I just want it to do it automatically. So now we are going and we added this new DR site to the availability group. Let me show you the dashboard. So here you see in the dashboard, you have your primary, which is AlwaysOn SRV3, your secondary, synchronous secondary in the same local data center, which is SRV2 with automatic failover. AlwaysOn SRV4, which is your regional data center, which has synchronous data movement, so it's synchronized, no data loss. And AlwaysOn SRv5 is my DR side with asynchronous data movement, and it is synchronizing with my primary. What did I do here? I did not use any resources of the primary to do my backups, so I offloaded the backup resource to my secondary and seeded my DR site with it, and all I had to do is go back to my primary and add the DR site. Okay, so now let me go back to the slides from current slide. Some things which I want to mention is the backup capabilities. I had talked about it earlier. I can take my backups from any replica, any secondary, whether it is synchronous or asynchronous. So I could have even gone to my new DR site and take a backup from that. You can also take a backup from your primaries. Log backups done from any of the replicas form a single log chain. That's why we always advise that save the backups centrally, just in case you have some application which manages your backups. We have a recovery wizard which makes restores much simpler. Some restrictions: you cannot do differential backups from your secondary. You have to do it only from the primary. And you can only do copy-only full backups from your secondary. The difference between what that does is it does not clear the differential bitmap. That's the only difference. All right. Now let me show you the readable secondary functionality. I am going to jump back into the demo. So let us assume a situation is going on right now. All your applications are pointing to your primary, which is AlwaysOn SRv3. These are your read-write main applications as well as your reporting applications or read-only applications. What we want to do is we want to remove these read-only applications and make it use some of the secondaries to do the reads from. In order to do that, the first thing I need to do is enable all the secondaries to allow reads or make them readable secondaries. To do this, I go to my availability group on the primary, right click, go to properties. You have this option called readable secondary. Here I have multiple options. One is read intent only. What this means is we have only if you use a keyword called application intent equals read only can you do reads from the secondary. The other is yes, which is I want to take any connection, any readable connection, even if it does not have read intent, the application intent equals read only to allow reads from it. I'm just going to select that. I'm selecting that for all the replicas. So anytime any of these replicas are in secondary role, we can do reads from them. I want to quickly touch on one other thing, which is connections in primary role. What this means is if you have a situation that you want to say that I never want my reporting application to ever connect to my primary, you can use this. You have multiple options. So allow only read-write connections or allow all connections. Please go to books online and you can read what these options do and how to use them. Coming back to my readable secondaries, I have set up all the replicas to be readable in the secondary role. I click OK. So at this point, I can do reads from any of the secondaries. I want to do something else as well. Now, if I want to do reads from my secondaries, from my application, I have to connect directly to my secondary. So if I want to do read from SRv5, in my reporting application, I have to directly connect to SRv5. I don't want to do that. I want to use something called read-only routing feature, which we are actually giving with AlwaysOn availability groups. What this does is it redirects your readable, your reporting application to a readable secondary that you choose. I'm going to show you right now how do you set this up, how do you choose what is that readable secondary you want to redirect to as well. All right, so let me go to my reporting application. I'm sorry, before I go to my reporting application, let me configure this. That's the main thing. I have a script to configure this. Unfortunately, this cannot be done from the UI right now. It has to be done through scripts or even PowerShell, I believe. Two things need to be done to set up your read-only routing. the first thing is you set up a read-only routing URL. What this means is, what URL should my primary redirect this read-only connection to? I'm setting this up for each one of the replicas. I'm saying for AlwaysOn SRv2, I want to use TCP, AlwaysOn SRv2, contoso.com, port 1433, do this for 3, do this for 4, and do this for 5. The next thing is I set up my routing list. Routing list is basically, for a given primary, which secondary do I want the readable connection to go to? An example here is I have said for AlwaysOn SRv3, if that is my primary, say I want my routing connection to go to AlwaysOn SRv5, which is my DR site. If 5 is down, then I want it to go to AlwaysOn SRv4. One thing to note here is it doesn't round robin the connections. It goes only to the first secondary which is available and a part of your routing list. So in this case, if AlwaysOn SRv5 is online and synchronizing, then all your readable connections will go only to AlwaysOn SRv5. Okay, this is an important point that I wanted to actually show you. The next thing, an example, if my primary is on AlwaysOn SRv2, I want it to go to SRv5, SRv4, and SRv3. This is just different examples that I wanted to show you. A use case that I've heard from customers is, say I have 2 replicas in one data center and 2 replicas in another data center. What I want to do is I want to go the read-only application to go to the closest replica. So I would set for one set of replicas my routing list a particular way, and the other set of replicas the routing list a different way. Okay, just some practical usage of this. All right, so let me run this. I have to run this from master, and I have to connect to the primary to run this. So I'm going to connect to AlwaysOn SRv3 and run this. So now it is going and creating the routing list. The 2 things it is showing below, let me actually expand this just so that you can quickly see this, is how do you see whether your routing list is set up properly, or what is your routing list. We have provided 2 DMVs, availability routing, read-only routing list, which says for a particular replica, what is the read-only replica and what is the priority, routing priority order. To find out which replica it is, you can run sys availability replicas, which actually gives you for a replica ID what is the name of the replica. For example, for the one above, we are saying 3CF, which is AlwaysOn SRv2. When this is the primary, then what do we want the secondaries to be? Okay. All right, so now let me show you that this works. I have a reporting application. First, let me connect it to the primary. So I will use businesscon, which was my connection, which was my availability group listener, change. You see, in this case, my reporting application is automatically connecting to my primary. I want this to connect to the secondary. In order to do that, let me just stop this application actually. Go back to the connection string. I am going to use this keyword called application intent equals read only. When I do this and click change, you see I'm getting redirected automatically to my readable secondary of for this given primary, which is my DR site, and my reporting application is running off this. So as you can see here in my routing list, SRv5 was the first secondary, and I'm connected to SRv5 because I used application intent equals read only. All right. Now let me go back to our presentation and continue from here, from current slide. I just did a demo of my readable secondaries. What did I do? I set all the secondaries, all the replicas to be read-only in readable in secondary role. Then I set my routing list. Then I went to my application and added the application intent equals read-only, which automatically connected my reporting application to my readable secondary. One thing to note with readable secondary, there could be some data latency between your primary and secondary. This is also true in synchronous secondaries. The reason is because in synchronous secondaries, we guarantee that the data has been written to the log file, but we don't guarantee that redo has been completed. So, for example here, if a commit transaction comes in, goes to the log cache, we flush it to the log file on the primary, and in parallel also send it to all the secondaries. The secondaries receive it, send it to the log cache, and they could write to the log file, so they harden the log, as well as sometimes redo can happen in this case. However, only once that the log is hardened on the secondary do we give an ACK back, and when we give this ACK back is when we commit the transaction. When this ACK reaches back to the primary, we commit the transaction to the user in synchronous secondary mode. Okay. However, redo has not completed, correct? So you can only do reads when the redo has completed and it's written to the data file from the log file or from the log cache. So that is why even in synchronous secondaries, the log could be there in the log file, but it might not have been written, hence there could be data latency. Always monitor what is your redo queue and things like that. Okay. So let's talk about the current topology at this point. Your current topology is I have always on SRv2, always on SRv3, always on SRv4, and always on SRv5. Sorry, I did the failover. That is why in this case my primary is always on SRv3. Assume I had done a failover back to SRv2. This slide is made that way. If SRv2 was the primary, then I have my local data center with SRv3, which is my automatic failover set, SRv4, which is my regional data center, where I'm saving data because it's synchronous, and my asynchronous DR site in SRv5. What are some of the additional things that I did? I took a backup, or I'm taking backups from SRv4, which is my secondary. I'm not doing the backup, or no resources are being taken from the primary for this. And I'm running my reporting application of SRv5, which is my DR site. So I'm again saving resources from my primary because my reporting applications can be pointed to other secondaries. Okay, that is the usage of our active secondary features. Sorry, I think I actually skipped up a few slides. So let me go back. And now let's talk about quorum configuration. Here let's talk about why we need quorum configuration, what are the prerequisites. Let's do a demo of the quorum configuration. Let me start with prerequisites. For always on availability groups, always on, you need to have Windows Server 2008 and above. If you are having failover cluster instances as a part of your availability group, so say you have two failover cluster instances in two data centers, both of these to be the part of the same availability group. First of all the nodes have to be the part of the same Windows Server failover cluster, and you have to apply this QFE, which is 976097. The reason what this will give you is enable you to have shared storage for a set of nodes in your cluster. So you can have two separate shared storage for each of the failover cluster instances. One thing to note, availability group also works with direct attached storage, and that is what I'm using in my demos. The second QFE that we say, or we highly recommend everybody does, is this KB 2494036. This is what gives you the ability to set your node votes for your quorum. I'll show a demo of this. Another thing for Windows Server failover cluster instance, all nodes have to be in the same AD domain, even if it is across data centers. To create a Windows Server failover cluster, you need to have a domain account, administrator on all machines, ability to create computer objects and read all property rights in AD. There's a detailed article on requirements to create a cluster. Please go and read it if you want to. All right, so now let's talk about why are we talking about quorum settings? One of the main reasons why we are talking about quorum settings is, let us assume a scenario where SRv2 and SRv3 is in your primary data center. SRv4 and SRv5 are in separate data centers, and your primary data center, your local data center, loses connectivity from the rest of the data centers. What happens in this case is the way clustering works is for quorum to be maintained, it needs a majority of votes, and this is how it prevents split brain. So in this case, there are 4 nodes in the cluster. Each of the nodes have 1 vote. In case your primary data center loses connectivity from the rest of your data centers, you have only 2 machines in your primary data center. So it has only 2 votes, and a majority in a 4-node situation is 3 votes. So your cluster will go down, and hence if your cluster goes down, your AG availability group will go down and your application will go down. This is why it is very important to set your node weights or set your quorum correctly. Alright, to set a quorum, it's a 2-step process. Set 1 vote for the replica, that is the primary. If you have an automatic failover target, then give that replica a vote as well, and set 0 votes for the rest of the replicas. Next, if you have an odd number of votes, then use node majority quorum. If you have an even number of votes, then add a witness to this and use node majority, or use node and file share majority. In my particular case, because I have a primary and an automatic failover pair, I have 2 votes, and hence I want to use the second option. In my case, I'm going to do a demo right now for using node and file share majority. Alright, so let me jump into the demo. I can minimize SSMS for this, and I'm going to do this whole demo from Failover Cluster Manager and PowerShell. So in order to change the quorum configuration, what I need to do is right-click the cluster, go to More Actions, Configure Cluster Quorum Settings, click Next. I'm going to select Node and File Share Majority. I have to configure a file share witness. This witness has to be on a server which is not a part of the cluster. So I have another server or another VM which I can use to do that. So I'm going to call that Hadron SRv1 show shared folders. Conveniently, I already have a shared folder which is file share witness. Click OK. Click Next. And there, I have changed the cluster quorum settings to be node and file share majority in this case. Now I'm going to set up the node weights. In order to set up the node weights, I have a script. I'm going to show the script to you guys. What the script does, in this script I'm saying, is 0 is for AlwaysOn SRv2, 1 is for AlwaysOn SRv3, 2 is for AlwaysOn SRv4, and 3 is for AlwaysOn SRv5. What I'm saying is for SRv2 and SRv3, I want to give it a node weight of 1 because one of them is my primary and one of them is my automatic failover target. And for the rest of them, which is my DR sites and regional data center, I'm going to give it a node vote of 0. So SRv4 and SRv5 will have a node vote of 0. Let me run the script. Votes, pry, file share. That's it. So now I have set up node vote of 1 for SRv2, SRv3, and SRv4 and SRv5 have 0. Let me jump back into my slides. So this is my new topology. SRv2, SRv3 have a node vote of 1, 4 and 5 had a node vote of 0, and you have a file share. So let us just assume that your primary data center loses connectivity from the other 2 data centers. Your cluster will not go down because now 3 of these things have the vote. The file share always has a vote. SRv2 and SRv3 have a vote. So a majority that your cluster needs to stay online is 2 votes. Hence your application, which is connecting your primary, will be online despite losing this connectivity. Okay, and let's assume if your primary was SRv2, even SRv3 goes down, even then SRv2 will always remain online. The reason is because it has two votes, one from the file share and one from itself. All right, I hope you understand the importance of setting node votes and looking at your quorum configurations at this point. All right, now let's talk about disaster recovery. Let's assume a situation where your primary data center, your local data center goes down. Your application is down, your line of business application is down. You have to do something to bring it back up as soon as possible. So let's go through a demo, simulate a situation, a disaster situation, and show how to recover from it. So I'm going to jump back into my demo machine. My primary is on AlwaysOn SRv3. Right click, show dashboard, just to show you what the current configuration is. Primary is SRv3, secondary SRv2, and my two other secondary replicas. SRv5 is synchronizing because that's my async replica. That's my DR site right now. Let me simulate a disaster situation. For that, I'm going to go to Hyper-V. And very simply, I will just turn off my two machines which were in my primary data center. Let's make sure these go off. So now what has happened? My application has lost connectivity and my customers are down. So I need to perform a DR situation right now. I'll go to AlwaysOn SRv5. I'm on that machine right now. I will start the cluster in force quorum mode on this machine. Actually, I want to show this to you as well. So if I do a refresh here, you will see that the cluster is unable to load any data. It's trying to pull information, and the reason is the cluster is down in this case. And hence my availability group and my application is down. So now let me bring up the cluster in force quorum. To do this, I can do net start class svc /fq. Start the cluster in force quorum. So it is saying the cluster has started. I will go back. You can see here as well in the cluster manager, the cluster is running in force quorum state. It's saying force quorum state. This is a warning because there is a risk that if the other nodes come back online and they're not talking to each other, that could also become the primary. So there could be split brain situations here. So the first thing, or one of the important things that you need to do when a cluster is running in force quorum is re-evaluate your node votes. In order to do that, I have a script here which is votes dr. What I'm doing in the script is I'm saying for all the other replicas, SRv2, SRv3, SRv4, set the node vote to 0. The reason is currently if you look at node votes, if I run my script which is votes view ps1, the machines which are down have a vote, but if they come back online, they could form a cluster, or they could form a quorum and say I can start the service here. You want to prevent that situation. So I will run my votes dr. Oh, I'm sorry, in this case for some reason the cluster is trying to still connect to SRv3 even though it's down. Let me rerun this. Okay, so it has set a node vote. To confirm, I'm going to run the view. It has said that every other machine has, or every other replica has a node vote of 0, and only AlwaysOn SRv5 has a node vote of 1. That means even if the other replicas come back online, they cannot form a quorum. Let us go to our cluster manager and confirm that it is not running in force quorum right now. And that's what it's saying. It is running in node and file majority. Now let me bring the availability group online. In order to bring the availability group online, I need to connect to AlwaysOn SRv5. If I do refresh, you will see it's resolving. That means the availability group is offline. Right click, go to failover. Actually, let's show the dashboard here. It says your availability group is offline. I can say failover. Next, this was an asynchronous commit replica, which was my DR site. Hence, I could potentially have data loss when I fail over to this. That's why we make the customer confirm this. The data loss is because asynchronous, we do not guarantee that the data is written onto the log file before we act back to the customer. Next, finish. And now we are bringing the availability group online on this particular replica. When we do this, our application can automatically connect to this availability group. Okay. So here you see your availability group is online. The replicas which were down, it shows red because they are down. SRv4 is not synchronizing. The reason is when you do a force failover, you need to manually resume the databases from the other replicas which are still available. But your AG is online on AlwaysOn SRv5 and your applications can connect to this. So let's go to the application. Change. So assume your application was running. It was using the data source business connection or business con. As soon as the AG came online, your application would have again started running. Okay. So this is what I've shown in the disaster recovery situation. How do you bring your availability group online on your DR site? Let me jump back to my slides. Recap. Start the cluster service in your DR site using force quorum. Force failover your availability group to your DR site. In this case, it was force failover because it's an asynchronous replica. Reevaluate and change your node votes. Make sure you're not in force quorum mode when you go to your cluster manager. In the demo, I first changed the node votes, then I did the force failover. You could do it the other way as well, but you have to first start the cluster in force quorum. Let's do a quick recap. We talked about AlwaysOn availability group features, why we did this. We upgraded from database mirroring and log shipping to AlwaysOn availability group, created an availability group listener, connected my application to the primary using the listener and did a failover. Then utilized the active secondaries feature, did a backup from the secondary to seed a new server, my DR site, and then added that to my availability group. Connected my reporting application to my readable secondary, which was on my DR side, using read-only routing. Then we talked about quorum configurations. We changed the quorum configuration to node and file share majority quorum, set the node weights. Then we talked about disaster recovery, where we created a disaster recovery situation and recovered on the DR site. A few other things. All the examples, everything that I did today was with direct attached storage. So it is the topology on the left. If you as a customer have shared storage or failover cluster instances, you could even use that in an availability group. So my example on the right, it's a customer who has already acquired this. This is the flexible solution. The failover SQL Server, AlwaysOn failover cluster instance is what will contain the local HA, and you can actually failover outside this manually or force failover to other secondary replicas. In this case, I have one primary in my availability group, which is this failover cluster instance, and two secondaries. One of the secondaries is a failover cluster instance, the other is direct attached storage. So you can see the flexibility of the system. But all of this is in a single availability group. Here are some information and resource links if you want to learn a little more about availability groups. This is the page where you can go to, and a link where we have information on both availability group and failover cluster instances, downloads information, documentation, forums, blogs, and if you have any suggestions, please file them using Microsoft Connect. I hope you guys got a good understanding of the AlwaysOn availability group feature. We are very excited about it. Hope you learn about it and use it in your topology, in your environment. Thank you.